3D printing has unlocked small-scale manufacturing and rapid prototyping, from the home bedroom on up to big businesses. It's taken what was once considered sci-fi technology and turned it into everyday manufacturing reality. I try to push it beyond what folks think its limitations are on this channel in every video, because I want folks to understand that it's not just a novelty, it can be a really useful tool, but it does have its limitations. At the end of the day, it's just a dumb robot hot glue gun pushing out arguably weak plastics. But what if we could take the next step to curb some of those limitations? Well, that's where this machine, the Fibre Seeker 3, comes in. Plenty of 3D printers claim to specialize in carbon fiber. What they actually mean is they're using a filament that has fine bits of carbon fiber chopped up into it, which can provide a stiffer final part, but also harm layer adhesion. And by volume, there's usually only 5 to maybe 20% carbon fiber versus plastic. The Fibre Seeker 3, on the other hand, has an entirely different conceit. In the side of this machine is an entire spool of carbon fiber thread that is actually embedded into the extrusion of your print, creating an internal skeleton structure to reinforce it. Fibre Seeker 3 is not the first machine with this party trick, but those other units cost tens of thousands of dollars. This is set to be a lot more reasonable. There's a lot more to discuss with this machine, but let's get it moved over to the workshop side of my studio so we can test it out in the real world. Remember folks, team lift. I'm setting up the Fibre Seeker 3 in the workshop area because I got a few projects that have been a little hesitant to 3D print. This machine's continuous carbon fiber reinforcement should make them more viable. We'll start simple and work our way up in spectacle. Timestamps are in the description if you're impatient. The capabilities of this machine place it squarely, in my mind, in the tool category. That's why it's on top of a toolbox in my workshop area. I'm gonna get right into printing up a part for my workshop space. These jack stand hooks. I had some metal ones of these in my last studio that I've misplaced, and I was always a little hesitant to 3D print these in other basic materials. But with that carbon reinforcement, I want to see how this is going to go. We'll talk more about how this machine achieves its party trick throughout this video. For now, I just want to get printing parts so we can get rolling with our projects. We're going to load up this clear PETG that the FibreSeeker team sent over when they sent the machine. That's a good segue to mention this video is sponsored by FibreSeeker. They want me to show you using this machine in my projects and how I can apply this technology. That said, I fully intend to discuss honestly with you some of the experience I've had using this. It's an earlier prototype machine, and there's been improvements since I've had it, and there's only going to be further improvements before release. So we'll talk about that later in the video. I do want to note the only reason we're using clear PETG is because you'll be able to see the fibers embedded in it, so it's a really good demo. You'll be able to use whatever materials you choose to use with this machine, just a black print with black fiber embedded in it, you're not really going to see it in the finished part. This is not a closed ecosystem that has to use their materials. You'll be able to embed it into Polymaker, Elegoo, whatever filament you want to use in this machine, which gives it a leg up over the much more expensive options that are out there. I ran off a handful of my jack stand hooks. I thought I did 4, but I only did 3. These have a unique design element to them. The hole where the screw will pass through is closed in because of some of the intricacies of the way the Fibre Seeker works. It doesn't just continuously carbon fiber print through open air, so I couldn't have an open hole and have carbon reinforcing above my screw hole. Even then, I had to get the settings right in the slicer because a couple of these I printed and had the settings wrong, so I didn't get the carbon fiber where I intended it to be, and one of them I did get it where I wanted. So there's a learning curve as to how to operate this thing and to design for it. We'll touch more on that as we go. For now, let's get these up on the wall. Install's rather simple. Locate the hook on the wall, pilot drill it a little bit, follow with the hammer drill fully, and then tapcon it to the concrete. Repeat a few times, and I've got jack stands up off the floor, hanging on the wall, better organized. I still need to print a 4th one for one more jack stand, but I can grab one off of here, I can put it back up on the wall, and it's hanging on a 3D print. Only time will tell whether they're going to creep and give. I'm hoping the carbon reinforcement, the rigidity it's providing right now, will continue to do so under continuous load. Check my socials to see if it fell off the wall at some point. For now, I'm really happy with this. I just need to print that last one. That means it's time to move on to the next problem this area has, which is light. This area of the shop has a 12-foot by 14-foot shop door here. Not only is it the coldest spot in the studio, that's a future project, but it's also the dimmest spot. So it ends up where things just collect because it's the hardest space to work in. I need to correct that. Actually solving this problem is a bigger project we will be tackling in the future. For now, I want to take the first step, which is mounting one of these lights up in the corner, shining down into the space to illuminate it so I can get some work done around here. I've been working since moving into Mandic Labs 2.0 off of rolling C-stands with lights mounted on them. They're really handy for quick, easy moving of setups, but I need more permanent fixtures, things that I can just come out here, flip a light switch, and get to working versus having to reset lights for every single shot. This light with the diffusion dome that's going on it is not the lightest thing. I could see hanging this off of other 3D prints in the past, but I would have been a lot chunkier with my design than I am with this one. The carbon reinforcement is letting me think a little more materially efficient and still feel like I'm going to get similar if not better strength characteristics. The overall larger nature of this print gets us into a territory where the slicer can start to think smart about this and actually slice the design up with reinforced internal infill. This is a configurable setting in the slicer, but it figures out where the best place to reinforce the part is on its own. And looking at it, I can't question it picked the areas that I would think would be the highest stress on this design, and it reinforced those. With our design sliced, it's finally time to show you this thing printing. When printing is just a filament machine, it's relatively quick, with default speed being 200 millimeters a second in the slicer, and the hot end keeps up well with that. Switching to continuous carbon fiber is literally switching. This machine is IDEX, so it has two different hot ends. The right one is the filament only hot end, the left one is both filament and the carbon fiber. This ramping mechanism is pressed by the movement of the gantry to then switch between the two, lifting the filament hot end away from the bed when it's not in use, so that the main hot end, the continuous carbon fiber one, can take over. Once that switch is made and we are printing with continuous carbon fiber, things slow down substantially. We are going anywhere between 2 while going around a corner to a maximum of 30 millimeters per second while printing. This is all down to the way the system works. Filament is fed into the right side of this hot end. On the left side, that silver cone is where the carbon fiber thread feeds in. This is a co-extrusion hot end. Filament comes down, makes a 90-degree turn in the heater block, and then another 90 to come out the nozzle, where it picks up the carbon thread, which is lined up with the nozzle, and lays it into molten plastic. That plastic is liquid, so if the carbon thread is pulled too fast while it's printing, it gets jostled out of location. The carbon thread itself is 0.27 millimeter in diameter, which means it can't be pushed too fast or hard either. So we'll talk more about the way it's extruded later. For right now, you just need to understand that there are various limitations to the way that this extrusion process works, but you can still get some pretty solid prints out of it. The print has a really unique look with this clear PETG on the outside of it and then that carbon laid inside. It's just, I've never seen anything like it. Seeing that black in the depth, but then kind of the shininess of the carbon, it's interesting. For this particular design, I'm pressing in a heat press insert so that I can then thread a 1/4 inch bolt through the mounting point of this and then mount a grip spigot to it. This grip spigot is what a lot of lights are meant to attach to, and this light is no different. With our print in hand, it's time to put it up there. I'm mounting to the steel post in the corner of the shop as high as I can without interfering with the door, hopefully. It's cold outside, so I'm not going to open it up to find out. A couple of self-tapping screws through the mount, and now I'm ready to put a light up here. Of course, now that that mount is doing its job, you completely cannot see it, but it feels really solid. I'm quite happy with it. If anything, the only thing moving is this sheet metal post that it's screwed into, so goodbye me. One more trip up the ladder with this power supply and controller box to get this thing connected and wired up, and now I can remote control that light and have a mildly brighter work area. It's really doing quite a bit for not having any light here previously, but this studio lighting is going to be an ongoing project in here, I'm fairly sure, but this first step, I'm pretty happy with. Okay, it's time to really test continuous carbon fiber printing. I've shown you using it, but we're not comparing to regular 3D prints in that. So to show you really the spectacle of what this stuff can do, I printed up a handful of these chain links. I printed these in a range of materials, PLA, PETG-CF, and ABS, as well as PPS-CF, which is the material that so many folks think in filament printing right now is the end-all be-all strength-wise. When it comes to really testing these regular filament prints against CCF, I'm no German engineer named Stefan, I'm an American with a pickup truck. Which desperately needs new tires, so if you want to help support us getting better testing equipment, tires, please do consider supporting on patreon.com/MandicReally, like these fine patrons who help to make it so we can produce these videos for you on a regular basis and perform experiments like this. To produce some actual data test numbers, I picked up this crane scale, which is rated to 3,000 kilograms. It's meant to be hanging things to weigh them, so we're gonna find out how well it works when you're tugging on it with a pickup truck. To tie everything together, we're gonna be using these rigging slings that I've had for a long time. They're rated to 10,000 pounds in bridle configuration, which is what we're gonna be using them in, so hopefully they hold up. With the scale hooked up, our first print in place, which is the ABS print, bamboo ABS printed on the H2D. I'm gonna set this thing to peak so it'll hold at our peak setting. With that setup done, what I do now, I do for science. I can't actually see the print, so I'm just gonna creep forward till it gives. Gave. Test number 3, PETG printed on the H2D. This is PETG-CF, so chopped carbon fiber, not the continuous carbon fiber. Ease into it, just slowly. Broke. I honestly don't know what to expect from PPS-CF. We are preloading it right now. Truck is pulling against it. Time to hit the throttle just a little bit. I'm easing into it. Broke just like any of the other prints. I'm not gonna lie, I have no idea what to expect from the continuous carbon fiber print. We're easing into it now. Truck is pulling on it, sitting in drive, idle. Time to put a little throttle to it. Oh, it broke. Before we get to the test results, we should probably discuss what is it we just tested. Arguably, this was a tensile strength test. In a lab environment, you would have a dedicated testing machine, you would have coupons specific to it that you would then pull on and create your testing. This is clearly not the most scientific of methods. I can't be sure that the truck is applying the exact same proportional amount of force between tests. There's a bunch of variables at play here. But I'm working with what I had, and I was able to produce results from it. And I think these results are interesting. Things are definitely not quite how I expected them to shake out. ABS being at the bottom, I'm not shocked by. That material just doesn't have much in the way of ductility, aka stretch, which is why PETG-CF did as well as it did. PETG can stretch, it can elongate a little more before failure, which allowed it to register higher in this particular test. But I expected more from the CCF print. There is a factor that I haven't discussed yet though, and that's that the print actually was a failure. You see, the continuous carbon fiber print that I tested here was only 6mm thick. All of the other toe lengths were 9mm thick. The print on the Fibre Seeker 3 ran out of carbon overnight while I was running it, and didn't stop the print. It just kept trying to print PETG on top of it. It made a right mess out of things, but it did get 6mm thick of carbon into the print. So what you just saw in my test results was actually a failed print. So I ran another round of tests, a full 9mm thick continuous carbon fiber print and another PETG-CF. So shockingly, when you put a 9mm print against another 9mm print, the results are a fair bit different. The CCF definitely held its own a lot better this time. That said, I did notice that the 604 kilograms it registered was mid-test when the truck kind of tugged on it a little bit. At the actual failure point, it didn't go any higher, so I don't know if it was already stressed and then broke easier after the first pull, or my crane scale didn't register properly because it's not really intended for this. Who knows, but we definitely got the strongest result, spinning tires, from the CCF print. With our very scientific testing out of the way, let's talk about my experience with the Fibre Seeker 3 so far. I want to note that this is a beta unit. This machine is indicative of the release units, but I know there are updates already planned, such as an add-on chamber heater that mine does not have. It's going to get it up to 65 degrees Celsius. There's a link in the description to the Kickstarter campaign for this project, so you can check out the latest information, back it if you want to. Remember, you are backing a project, not necessarily ordering a product when you place a Kickstarter backing, but they've already raised over $2 million, well beyond their intended goal, so I'm expecting these are going to ship just fine. Part of why I say that is the CEO from FibreSeek, when I was having problems early on with the machine, flew over to the US from China, came to my studio here in Portland, Oregon, and worked with me for an entire day. We tweaked and tuned and checked and rechecked and discussed some of the design elements and improvements I saw that could be implemented, and I've already seen some of those things trickle into updated designs since then. You may have noticed at the beginning of this video to now, my studio looks a little different because I've had this machine for a while now. I know for a fact things are being updated through the power of buying two. Okay, I didn't buy these, but I have two of them. One that they sent me a while ago, and this one I just recently got that has already worked a lot better, but not perfectly. Currently, the carbon is not feeding. It'll feed through its Bowden tube, as it is a Bowden drive on the carbon extruder hot end. The plastic one is direct drive. Once it feeds through the Bowden tube and hits the hot end though, it hits the restriction of having to merge with the plastic, and it just stops. It slips in the extruder, which is a belt drive design. It's neat, though not easy to service at all. And I have the side panel off because there's no access panel for that extruder. So if it acts up, you have to take a whole side panel off the machine. There really should be an access door for that. But there's also going to be an updated extruder design. They've already shown that that's one of the things that's coming to release units. While we're in the side here, the main board in here is custom for this machine, and it's running a rock chip powered compute module style design because this is a Clipper powered 3D printer. I've been using it through the Mainsail web interface while I've been running the machine, and I really like that familiarity with what I know with this new tech. The biggest update from the first machine I got to the new machine is actually just down to the hot end in this. As I showed earlier, it's a unique design in that it mixes the plastic and the carbon in the hot end to create a co-extrusion in the tool head of this machine. The earlier design had a multi-piece hot end heater block where filament just constantly leaked out of it on me, and it got to the point where it just was not successfully printing. The new design is a much better design, not dissimilar materials, it's not multi-piece, it's more of drilled passages into the block to allow the flow of plastic, and has worked significantly better. The earlier unit had a problem with switching from the plastic-only head to the continuous carbon fiber head. This new unit has reliably worked every time. I noted that the carbon ran out on one of my test link prints, and then it failed. It has a carbon filament sensor, but that didn't work. I don't know if there's a firmware issue, if there's a sensor issue, I don't know. I would expect when it runs out that it would stop and then go through a process of reload and get the print going again. It didn't happen as I would anticipate it should. And with that, I should also note that I'm sure a lot of folks talking about this machine, I haven't watched other videos, are focusing on the carbon. And I have throughout this entire video. But it's still just a competent, quick plastic 3D printer. It is an IDEX setup. You don't have to switch tool heads. So if you just wanted to use this machine to print plastic and don't need to reinforce it with carbon, the machine is fully capable of doing that and doing it pretty reliably. Is the Fibre Seeker 3 for everybody? Absolutely not. If you are printing benchies all day long or flexi dragons, this machine is not for you. But if you can see the potential in carbon reinforcement in your prints, the strength of it, the ability to produce strong, lightweight components, race teams for cars, motorcycles, engineering shops, manufacturing shops, there's a lot of additional functionality being able to make your own carbon, and I believe they have a glass fiber as well, reinforced prints. I haven't mentioned this carbon is $40 to $50 a spool. I don't know exact pricing at the moment, but it's pretty darn reasonable in the scheme of things. I've gone through like 1.5 spools in my testing so far, and I was printing like 100% carbon on the toe link, so that's definitely beyond what most folks are going to be doing. This has been the Fibre Seeker 3. I hope the rough edges get polished in the long run, but I'm really happy with the prints that I've gotten off of it. I need to get that updated extruder to get mine back up and running so I can do some more prints. Look out for maybe some updates on social media as I play with this more in the future. Find the Kickstarter link in the description if you're interested in checking out the information of this project or backing it. You can find that link down there. Thanks again to FibreSeeker for sponsoring this video, and I hope you folks found this interesting. Coming to you from Mandic Labs 2.0, sponsored by Prusa Research and PCBWay. I've been Alan Mandic, MandicReally, and this is the Fibre Seeker 3. All right, folks, get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See ya.